Okay, good morning everyone. That if you are starting module 2, okay, let us start with new topic altogether. Let us start with the top trust. Have you heard of the word trust? Anyone? Are you all able to see this slide? Topic 2.5,
Yes, sir.
subtopic 2.5. Okay, now. So my question to you is that have you heard of the word trust? This word trust, have you
Yes,
heard
sir,
of
they
it?
are used in shed, metal sheds.
Okay, now. Okay, metal shades. You so one person knows. Okay, what it is meant for? Trust. What is the use?
So to support the
Someone is saying
structure.
to support the structure. Okay, very good. Look here. Truss is basically a structure. Truss is basically a structure which is used for carrying loads. You are right. It is used to support a structure. So basically, it is meant for carrying loads. Now, let us say that we have got a weight W, okay, which has to be kept at a certain height. We have got a weight W which has to be kept at a certain height h. Now, in order to keep it at a certain height h, what we do is that we add a link here. ऐसा क्या किया हमने? एक link बना दिया. Let the name of the link rod or link be A. So what we are able to do is that we are able to support this load W at a height h, okay, with the help of this link AB, okay. Now, if the weight is very high, will this link remain stable?
No, sir.
You got the question?
No, sir.
Yeah, Parth. Will it remain stable
No, sir. It will
if this
bend.
weight W is Tell me.
It will bend the support because of its
Yeah,
high
it
weight
will
and
bend the
the
support. There
component
will
of.
be some type of turning effect that will occur here. Okay, so this B will come somewhere downwards. Okay, and the weight will also come downwards. So in order to support this AB, to give it more support, what we do is that we add another link. This thing is your ground level. Ground level है आपको. We what we do is that we add another. Let us call that as BC, so that both of them, so that both the links AB and BC, they are able to support this W now. Is that okay? Now, the problem here again is that suppose we increase this weight W to a much higher value. Okay, we go on increasing this weight W to a much higher value. Then what will happen to this BC link? Will it remain stable? Will this point C, will it remain stable at the ground level, or what will happen? Please tell me. If the weight W is very high, what is going to happen at C? Will there be some movement at C, or will the C point remain stable?
C will start moving outwards.
Outward means in which direction? Rightward or leftward?
Right.
Right, sir.
Right,
Right.
sir.
So right. C will start moving in the rightward direction. Okay. Again, if C starts moving in the rightward direction, this weight W will it remain stable at the height h, or will it come down again?
Come down.
Come down, sir.
It will come down again. Now again, we have to stop this from happening. Okay, we have to stop this movement of W downwards. So what I do now is that till now I have already used two links. I have used two links here. I have used basically two members here. Okay, link value member. One is your AB, another one was your this BC. Okay. Now in order to stop that again, what I do is that I add C2A. Can you see this? C2A I'm adding. Okay. So even if the weight W is very high, will this C now be able to move rightwards? Yes or no?
No, sir.
No. So this movement rightward has been stopped. Stopped by what? By adding this new link, that is your AC. So we have got how many links here? Three links: AB,
Three.
BC, and AC. And of course, yeah. So we have got three links here, three members here, three links, three members we have got. These members are basically AB. These members are basically your this 1 second. Three members AB, BC, and AC. Now these members are joined at 3 points. One is point A, another is this joint B, another is this joint C. So here, these three members, are they able to support the weight W more or less or not? Please tell me now. Now,
Yes, sir.
yeah, they are able to support. So such a structure, okay, such a triangular type of structure which is used for carrying load, okay, is called what? It is called a truss. It is called a truss. And of course, it is not kept here like this, just kept here on the ground. We have got certain support here. All of you have studied the hinge support, roller support. So one side, let us say that we are having this hinge laga diya hai. One side, we have got a roller support. So such a structure which is used for carrying loads is called a truss, and this is one of the simplest truss. This is basically the simplest possible. Okay, and that is a triangular truss. Now you must have seen such structures a number when we go on adding these triangular structures one by one. Okay, have you seen such structures anywhere? कहीं देखा है कि नहीं ऐसा structure आप लोगों ने?
Yes, sir.
Yeah, this where this structure where you have seen? F
Bridges.
bridges. We have seen such structures on the sides of bridges. And give another example. Another example where you have seen this.
Sir, towers, electric
Yeah,
towers.
towers. Electric transmission towers. Have you seen that or not?
Yes, sir.
Yes.
Also, you must have seen them on mobile towers. देखा है? Also, you must have seen on roofs. Where? In auditoriums, stadium. You must have seen. Okay. So these are basically your truss. Okay, and they are meant for what? They are meant for carrying loads. Now these examples I am talking about that I am showing you right now. Look here. Look here. We are talking about this. Okay. We were talking about towers. So in these towers, can these towers, can you see the triangular structures here? दिख रहा है कुछ आपको triangular structure? Can you see them? All of them, these triangular structures are connected to each other. Then this is, I think, a mobile tower. Mobile tower. Again, another tower there. Can you see the triangular structures here? This side also.
Yes, sir.
Okay. So all of them are connected. Here on the bridges again. Look here. This is a triangle, 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 triangle. Here also again, triangle, triangle. ठीक है? ये यहाँ पे triangular structures हैं, all of them. Are you able to see this animation also? A truck passing over a bridge. This one. Okay. So these are some of the examples of So these are some of the examples of truss. Now, coming to again here also auditoriums. I have told you no. Look here. You can see a triangular structure here. Lot of triangles connected to each other. Okay, triangular structure here. So all of them are basically the truss structure and they're used for carrying loads. Now, this is coming to the definition of a truss. The definition again, you can say that a truss is an assembly of straight members connected at joint. Okay, and they are meant for what? These are each truss carries loads. Okay. Now, tell me one thing, if a load is acting here on the truss, let us say some 100 kilonewton load is acting on this truss. Okay. Will there be some stress that will be generated in the members or not? How many members are here? how many members are there in this truss? Tell me. How many members you can see here? How many limbs you can see?
Four.
Members.
Four.
Four.
4, sir. 5. 5.
What? Okay. Name them. Is AC a member or not? AC.
Yes, sir.
Here.
Yes, sir.
Next is what?
BC.
C. Next is what?
AB.
DB.
ED.
Next is what? AD. And last one?
BC.
Last one?
ED.
BC कहाँ है? BC तो मैंने लिख दिया. BC I have written here. BC. Last one? C to D. Can you see C to D?
ED.
C to D. That is the link. And how many joints are there? These are the. How many joints are there? Tell me.
4 of them.
These joints are A, C, D, and D. 4 joints are there. Now tell me one thing. If I'm applying a load of 100 kilonewtons here at this point, I find C. 5 members. What is going to happen? What's going to happen there? Will there be some stress that will be generated or not? Please tell me.
Yes, sir.
Some stress will be generated. Okay. So if taking simple trust example, it's a simple example. Let us say this ABC was my thing, that I am adding a weight of 100 kilonewton. Okay. Now if I am adding a weight of 100 kilonewton at point B in the downward direction, what should happen in AB? So will there be compression or tension? AB.
Attention.
नहीं बेटा AB में क्या होना चाहिए? ऊपर से मैं ऐड कर रहा हूँ ना. Look here. Again I'm drawing this. One second. A, B. This is my roller joint. I'm adding 100 kilonewton here. This point can be anywhere else because we have in this direction. Roller support is there, so it can take this. It will also not go. Okay. If I'm adding 100 kilonewton here, what should happen to AB? Will it elongate or will it contract? क्या होना चाहिए? What should happen there? AB. Yeah, everyone, please tell me what should happen there. Your part, tell me. If someone please tell me what should happen there.
Sir, it will elongate.
Elongate क्यों होगा? मैं
Sir,
ऊपर से
on
force
AB.
लगा रहा हूँ. हाँ, AB on है. क्या?
Sir, compression. And AC.
This AB.
Sir,
This AB is AB. I am applying a force at point B. So where will this point go? Will it start expanding or will it start contracting? Because A cannot go in. Okay. So this AB will be in compression. Similarly, the BC side, that will also be in what? Compression. And coming to this AC, it will be in what? At this point, there is
Extension.
extension. That is, I am calling it as tension. Okay. Now, tell me one thing. AB is compression. A compression. Okay. So external forces are acting on AB like this. Now tell me one thing. The stress that is generated here, the stress that is generated in AB, due to compression, will its direction be in or direction be outward in AB? Please tell me. One or two. What should happen? AB is in compression. So the stress which is generated, AB is in compression. So external forces I have shown here. I've shown the external forces here. Is it okay? So the internal stress which is generated, its arrow should be what? Inward or outward? Everyone please think and tell me.
Outward.
Outward, sir.
Outward.
This thing
Yes, sir.
outward. Okay, why outward? Yeah, Satvik, why outward? You are saying outward. Why? You are right. Please tell me why.
So,
Because it cannot
so
compress,
the
and so it tries to push, like what the force is trying to compress it.
Okay. It is not because the simple definition of stress. Look, I'm telling that I'm saying that some stress is going to be generated here. Tell me what actually stress is. Stress hota kya? What is stress? Define stress. Just one line.
sir, it's the internal force which is generated when an external force try to deform it.
Okay. So basically, you want to say that internal. Is that okay? ठीक है ना? So now if it is internal resistance, so the direction of resistance should be what? It will be opposite to the externally applied force. Again, I am saying the stress is internal resistance. That means it should be externally applied force. Externally applied forces are in this direction. So the internal resistance should be outward so that it opposes, okay, and not this one. So case 2 is right, not case 1. Okay. Similarly, if I'm saying that this AC is in tension, A is in tension. Okay, AC. Can you see the member AC now in the tension? It is one. So here, what should be the direction of the arrows here? Inward or outward?
Inward.
Inward, sir.
Yeah,
Inward.
we have to basically the stress will
Inward, sir.
oppose that. So it should be what? I'm sorry. It should be inward, something like that. Okay. So this is the direction of stress. Direction. Okay. Now, so whenever stress is loaded, you will always find that there is some stress that is generated in the members here, and these members may be in tension or they may be in compression. Okay. So this tension value and compression value we determine by using certain methods, method of joint, we use method to find that. That how do we do? We will come to that later on. Now, all of you please look at this stress. If you look at the stress, all the members here, how many members you can see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can you see 11 members here? Please tell me. All of you can see 11 members here, no? Now, Satvik, please tell me, all these members, 11 members, are they lying in the same plane or different plane?
Same plane, sir.
Same plane. Okay. Now, come to another example. Let us take another example of be a simple tripod, a tripod type of structure here. Okay, if I'm connecting them like this, top also I'm connecting. Let us suppose I'm connecting. How many members are there here? Please tell me. How many members you can see here? It is a slightly 3D structure. Tell me how many members you can. Tripod, have you all have seen? Tripod.
Six of them.
Six.
Six houses. One, two, three, four, five, six. Okay. Now you tell me one thing. If you have seen a tripod, it is something like that only. Okay. Are all these six members lying in the same plane or different plane?
Different planes, sir.
Different plane.
Different plane. So here in this case, all the members were lying in the same plane. Here the members are in the plane. This called as and this type of base truss. You got the reference? Plane truss or plane frame also we call. In this there are many times we use the word frame also. Okay, so we can call that plane truss or plane frame, and then we can also call it as space truss or space frame. So you all understand the difference between plane and space? Difference you understood now? Okay.
Yes.
So now this is the difference between plane and space frame. Okay, in plane frame, the truss they are lying. All the members of the truss they are lying in the same plane, whereas in case of space frame, all the members lie in the different planes. Okay, there is no one single plane in which all the members can lie together. Okay. Now another thing which we want to discuss now is that please tell me in this ABC how many members were there? How many members you can see ABC? How many members you can see? Please tell me. Your part, how many members you can see there?
Actually, my net connection is really slow, so I cannot see the image.
It's about
Same here,
Right
sir.
now,
Same,
you
sir,
are all
sir.
able to,
Same here.
this slide you are able to see or not? This slide.
Now we are able to see.
Yes or no?
There is this ABC now. Okay, no problem. This ABC, how many members are there?
Three.
Three members are there now. Okay. They are your AB, BC, and AC. One member was it support the load? Tell me. You all understood the question? When only one member was there, was it able to support the load? Yes or no?
No, sir.
No. When two members were there, was that able to support a load? Support the load? Two, only two.
No, sir.
No. So we added one more member, three. So after three, it was able to support the load. So such type of truss which are able to support a load without any appreciable deformation are called. Yes. Is that okay?
Sir, your audio keeps cutting
Yeah.
out for me.
Yes, sir.
sir.
Same here. Same here.
Same here, sir.
Yes, sir.
Let me turn off my video then. I've turned off my video. Just hold on for 1 second. Hold on. Okay, right now my voice is okay.
yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
Okay, just 1 second. What I was trying to say is that, okay, this slide is visible.
Mm.
This slide is visible.
Yes, sir.
Sir, Maxwell's truss equation slide is visible, sir.
The Maxwell one is visible.
No, sir. The
For Max.
drawing one.
The drawing one is visible.
Okay, now wait. Now this one is visible. Maxwell truss equation. Is that visible now?
No, sir, not yet.
Not, sir.
Okay,
Not
so
yet.
delete
Sir.
it. Let it come now. Let it come.
Yes, sir. Now come. Now
Now
it
it's
came.
visible, sir.
Okay, okay, okay. There is some net problem. No problem. Let it come. Now it is visible.
Yes, sir.
Okay. So what I was talking about is that we had a simple truss here like this A, B, C. The number of members here was M, that was 3. Number of joints was also 3. Now, I said that this truss is able to support a load. If I'm loading it at B like this, W, it was able to support the load. Now, it is very easy to find out whether this truss will be able to support the load or not. Let us truss is in this form. Will it be able to support the load or not? It is difficult to say. So for that, what we do is that we use the Maxwell truss equation, but M is equal to 2J minus 3. Okay. This is the Maxwell truss equation. M is equal to 2J minus 3. If this equation is satisfied, it means that we have got a perfect and able the load without any appreciable deformation. Okay. Now let us put this. Let us use this equation in this truss. How many members are there?
3.
3. How many joints are there?
3.
3. So if I use 2 into 3 minus 3, what do I get this side? This side is 3. What do I get this side also in RHS? What do I get in RHS, right hand side?
3.
2 into 3 minus 3. What will be the result?
3.
3.
So can I say LHS is equal to RHS? Or in other words, M is going to be equal to 2J minus 3. Is this equation satisfied or not?
A are the number of joints.
Right. M is the number of members, J is the number of joints. Okay. So
Okay,
is the
sir.
equation satisfied for this case or not? Yes or no?
Yes, sir, satisfied.
It is satisfied. So can I say that it is a perfect truss? It can support load?
Yes, sir.
Okay. Now, similarly, it is not able to support the load. This M not going to be equal to 2J minus 3. It will be M greater than 2J minus 3 or M less than 2J minus 3. So two cases can be there. If M is not equal to 2J minus 3, M will be either greater than 2J minus 3 or M will be either less than 2J minus 3. Such cases are called as imperfect. Such cases are called as what? Imperfect truss, and they are basically unstable. Okay. Stable. Imperfect truss is unstable. Okay. M is not equal to M actually. M is not equal to 2J minus 3. If it is, if it is greater than 2J minus 3, we call it redundant truss. And it is less than 2J minus 3, we call it deficient truss. Okay. Is it okay now? So let us see some examples of perfect truss and imperfect truss. You have to use the formula M is equal to 2J minus 3 in order to determine whether the truss that is given to you is perfect, imperfect, or perfect, redundant, or deficient. Is that okay now? So come to this case. Please tell me what is the number of members here? Can you see this new slide here? A number of truss are given.
Yes,
Yes,
sir.
sir.
Okay. So the one which I have picked, please count the number of members there. Tell me what is the number of members here. This one
7,
we have done. You come to this one. 7.
7,
Look here. 1, 2. Okay. Let me also calculate. 1, 2, 3, 4, 5, 6, 7. What is the number of joints here? Tell me.
5.
5, 5.
5. So I'm also calculating.
Sir, 5.
Okay. And 5. So J is equal to 5. Now please use the formula M is equal to, I'm sorry. M is equal to 2J minus 3 and tell me what type of truss this is.
Perfect truss.
So M is
Perfect
7,
truss.
2A minus 3. Okay, 5 minus 3. So that is also equal to 10 minus 3. So that is equal to 7. So this one is what? Your perfect truss. Okay. So if everyone has done that, let us come to this case now, lower one. What is the number of members here and what is the number of joints? Please tell me.
So there are 4
9
members.
and 5. So 9 and 5.
5, someone is saying. Let
9
me
and
also
6.
calculate. Okay, 9 and 5. 9 and 6. Okay, let's
And
1, 2, 3,
6.
4, 5, 6, 7, 8, 9. 9 members are there. Coming to the number 1, 2, 3, 4, 5, 6. J is use the formula M is equal to 2J minus 3. M is equal to 2J minus 3. So what do you get? M is equal to 2J minus 3. M is 2 into 6 minus 3. So that is 9 is equal to 9. Let us call this as perfect. Okay. Now, so again it is a perfect truss. Now come to this one. Please tell me, can you see this animation here?
No, sir.
Hello.
So just a
This one
static
figure you can
picture.
see now. Okay, no problem. This one which I have ticked just now. Can you see this? Blue colored arrows are there. Please
Yes,
tell
sir.
me what is the number of members here. See whether it is a perfect, imperfect, whatever it is. MJ you calculate now. Everyone please calculate M and J.
Sir, 11 members.
Okay.
7
7
7
joints.
joint.
Are
joints.
there? Okay.
Joints.
Everyone please
Imperfectly.
calculate.
परफेक्ट होगा ना सर, तो परफेक्ट जो परफेक्ट ट्रस है.
Okay. So what are you guys saying? M is equal to what? क्या बोल रहे हो आप लोग? Please tell me.
11.
M is equal to 11. And J also you have calculated?
7.
7.
J you are saying 7. Let me also calculate. M if you are saying 11, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11 that is. J is equal to 7 you are saying. 2, 3, 4, 5, 6. You are right. So 2J minus 3. So 11 is equal to what? 2 into 7 minus 3. So 11 is equal to 11. So again, this is your perfect truss. Okay. Now, such questions may come in exam, and you will have to use the formula max, and you will have to determine whether the truss is perfect, imperfect, whether it is deficient, or whether it is redundant. Okay. Now, come to other slide. Let us see some more questions here. Can you see the new slide now?
Yes, sir.
Okay. Now, tell me about this square one. Use the formula again. Tell me about this square one. Middle one, middle one. Please tell me, everyone. Please calculate and tell me.
Redundant. Sorry, deficient.
Okay. Let everyone calculate. What about others?
Sir, deficient.
Deficient. Okay. Now let me also calculate. Okay. Let us say that find out the number of members and the number of joints. This is number one member, member two, member three, member four. So M is 4. Okay. Sorry. One second. Now M is equal to what? 4. Coming to the number of joints, this is your joint number 1, this is your joint number 2, joint 3 and joint 4. J is equal to 4. Now let us look at the formula. M is equal to 2J. M is 4 here, this side 2 into 4 minus 3. This side we have got 4, this side 8 minus 3, that is your 5. So the number of members is coming less than 2J minus 3. Is that right? Everyone can see that? For this case, everyone can see that now.
Yes, sir.
Okay, so what should we call this as? Perfect or deficient?
Deficient.
Deficient.
Okay, deficient trust. Okay, now another example is given here. This one. Okay, now please tell me what is the number of members here? What is the number of joints? The middle one, the diagonals are meeting. Okay, diagonals. Where the middle one, where the diagonals are meeting, that is not a joint. It is just overlapping. It is not a joint at the center. At the center, there is no joint. It is just overlap. Now, please calculate and tell me.
Redundant.
Redundant. Okay. Let others. What are you getting?
Redundant.
Redundant.
Okay. Now let me also check. Okay. Let us check. This is my member number 1. This is my member number 2, 3, and 4. 5 and 6. So M is equal to 6 in this case. Coming to the number of joints, 1, 2, 3, 4. J is equal to what? 4. Put it in the formula. M is equal to 2J. I will put it in the equation. Sorry. M is equal to 2J minus 3. M is 6. This side 2 into 4 minus. This side we have got 6. This side we have got 5. So what we get 6 greater than 5. That means M is greater than 2J minus 3. So it will obviously be redundant. I'm sorry. Okay. So in this way, a number of figures may be given, and you will have to find out what type of truss it is. Again, I am telling you, a perfect truss will be able to carry deficient and redundant. They are not stable. They are unstable. Okay. They are not used for carrying loads. So, as a engineering mechanics student, you have to determine whether the truss is perfect, deficient, or redundant. Okay. What trusses that we have already known. Okay. Now, and what type of forces are there in the truss? Tensile and compressive. That also we have studied. What is the nature of the arrows? Okay, nature of the truss. Nature of the stress. Okay, what should be their directions? That also we have studied. Okay, now let us see some more things here. Okay, 1 minute. Now, 1 second. One thing I'm giving you just an idea. This thing is also in the form of an experiment. Okay, all of you can see the blank slide here.
Yes, sir.
Yes, sir.
Okay, now, okay, so the next thing that we have to do after we have determined the type of stress, that the next thing that we need to do is that we need to determine the magnitude of stress generated in various members of the truss. ठीक है, अभी मैंने बताया ना थोड़ी देर पहले, just few moments back I told you ना that if you are taking a simple truss, this is your hinge support, this is roller support, and the load of, let us say, 100 kilonewtons is acting at point B. Okay, let us say this is 60 degree. Some angle will be there, 60 degree. Let us say this is your 5. Okay. Now, if I'm applying a load of 100 kilonewton here, we just found out that there is going to be what type of a stress in AB? What type of stress will be there in AB? Compression or tension?
Compression.
Compression. Oh, so this will be in compression. Can I show the arrows like this, inward arrows?
Outward.
कंप्रेशन जब इनवर्ड होगा, मैंने वही तो बताया था ना पिछले
अच्छा,
स्लाइड में.
450. Yes, yes, yes.
स्ट्रेस अंदर में जो स्ट्रेस डेवलप हो
Yes,
रहा
yes.
है इंटरनल, दैट इज F1 इनवर्ड्स होगा ना, वो दैट आई explained that now why it is inward, because it is resistance. I'm sorry, it should be outward. It is compression. I'm sorry, compression. One second, I'm sorry, it is in compression. So the direction of arrow should be what, inward or outward? Stress
Outward.
out. Yeah, sorry, I'm sorry, it is your outward. Similarly, what about BC? BC is in what, tension or compression? BC, compression. So here also the arrow should be what, outward. It is, the arrow is denoting this stress outward. Achha, what about AC? Tension or compression?
Tension.
Tension.
Tension. So here the direction of arrows of the stress, inward or outward?
Inward.
Inward. Okay. Now, so something like this. Is that okay? Now, our next aim is to determine the values of this F1, F2, and F3. समझ में आया बात? You understood this now? Our aim is what? To determine the values of this F1, F2, and F3. Now that can be done, this thing, and also their name, whether it is compressive or whether it is tensile. That also we have to determine for each one of them. We have to determine. Now, this determination of the nature and magnitude, we have to determine both and compressive or tensile. So this determination of magnitude and nature of the stress in the various members, that is called as what? Analysis of stress or frames. Okay. Understood this? This determination is called as analysis of stress, analysis of frames. Is that okay? Now, this can be done in 3 different ways. It can be done 3 different ways. Number one is your method of second one is your method of sections. Third one is your graphical. Everyone is getting this? करना क्या समझ में आ रहा है ना? Please. Everyone is getting. We have to determine the values of f1, f2, and f3 also. It can be done in 3 different ways. It is basically called as analysis of truss or analysis of frame. So ways, method of joints, method of sections, and the first two methods, method of joints and method of sections, that is in our syllabus. The third one, that is the graphical method, it is not in our syllabus. Okay. The first two methods are in our syllabus. The last method, that is the method of that is the graphical method, not in. So we have to just study the method of joints and not the method of and the method of sections and not the graphical. These methods are what? They are used for analyzing the truss or the frame, and they are used for determining the nature and magnitude of forces in the truss. Okay. Now please tell me, at point A, what type of support is there?
Your voice is breaking.
Okay. One second. At point A, what type of support is there? If you can see the slide.
Hinge support.
In support. So what type of support reactions will be there?
Horizontal and
At point
vertical.
A.
Horizontal and vertical.
Right there, H and VA. Is that okay? Is that okay? HAVA.
Yes, sir.
Similarly, at C, what type of support is there? At C.
Roller.
Roller. So what reaction you observe there at C? Reaction at C.
Vertical.
Vertical.
Vertical. Oh, so can I write it as HC? Is that okay? Okay, HC. Now, is that okay now? Till here.
Yes, sir.
Now let us determine the values of VA, HA. Forget about the internal forces. Internal forces we will consider. What will be summation fx is equal to 0? Please tell me. Someone please form the equation for this. Only external forces which I have marked a blue color. What mean fx?
VA equal to 0.
Yeah, VA is equal to 0. Similarly, what will be summation Fy? I'm sorry, Fy is equal to 0. Tell me.
HA plus HC is equal to 100 kilometer.
HA plus 100. Okay. So, and summation of moment point A is equal to. What will be the equation there? Please tell me. Point A is here. Tell me. summation of moment about point A. Equation, please tell me.
Minus 100 a by 2 plus
Minus
hc
100 into, this is your 5 na. So can I write 5 cos 60
5. Okay.
and next can I write plus hc in, okay, 5 cos 60 not. Yeah, 5. Yeah. Next what?
HC into 5.
It is an equilateral triangle. This length should be what? AC is equal to what?
5.
Can I write HC into 5 is equal. So what will be value of HC? That much you tell me, and let us finish the class. HC, what will be the value of HC? Please tell me.
50.
HC will come as 50. It will come as 50. HC 2. 1 second. This is 1 by 2. 50 into 5, 250. Yeah, HC will come as 50. So if HC is 50, I put this. What will be the value of HA? HC is coming as 50. Okay, HA plus SC is equal to 100. Okay. What will be the value of HA then? HA.
50.
50. So have we been able to determine all the support reactions here?
Yes, sir.
We have determined all the support reactions now. Now next what we do is that we use the method of joints to find out this value of F1, F2 and F3. Okay. That sir will tell you in the next class because today time is also over. Okay. So till now you have understood what a truss is, different types of truss, perfect, imperfect, all you have understood. Okay. Is that okay?
Yes, sir.
Yes, sir.
Okay. Okay. So I think we will end the class now. Okay. We will end the class now. Thank you. Thank you. Time is also
Sir,
over. So
attend-
we will end the class now. Thank you very much. Thank you.
sir, attendance.
Attendance.